Algebra 1 Summer School, Unit 4, Topic 1B, Lesson Video. So this lesson is about zero and negative exponents, or exponent rules. Alright, so the basic things we need to know about zero and negative exponents. Anytime a number is raised to the zero power, it's going to equal 1. Anything to the zero power equals 1. When I have a negative exponent, this one gets a little bit tricky, but if you remember the rule, you should be good to go. Anything with a negative exponent ends up having to move to a different spot in the fraction. So I like to explain this in terms of a house. All right, if I have a to the negative n, all right, let's pretend the a to the negative n is living in a house. A to the negative n is in the numerator of the house, or the top. He's on the first floor. But a is really grumpy because his exponent is negative. So what has to happen is we want to make that exponent positive to make a happy. So in order to make it positive, a is going to move to the basement. Well, when a moves to the basement, he's really happy. His exponent becomes positive, and he's replaced by a 1 in the numerator. Okay? That's how I get my answer. So we're going to start with the most basic of basic problems here, and then we're going to combine them together with different properties and make these problems a little bit more complicated. So, starting with 9 to the negative second. So this fraction is over 1. When I have a negative exponent, remember it's not happy on the floor that it's on. So I need to move that 9 away to the denominator of a fraction. That denominator gets a positive 2 as an exponent, and it's replaced by 1 in the numerator. Well, let's simplify this. 9 squared is 81. So the final answer here is 1 over 81. All right, the next problem. I have 2. Negative 3.6 to the 0 power. Well, the rule is that anything to the 0 power equals 1. That's it. That's the whole problem. 4 to the negative 3 is very similar to the problem right up above. It's already over 1. It's in the numerator. So to make it happy and positive, that 4 has to move to the denominator with a positive exponent. The 1 replaces it. Then I'm going to simplify 4 to the third, which is 64. So 1 over 64 is your final answer. Finally, in number 4, I have the whole fraction is raised to the 0 power. And again, simply, the answer is 1. All right, now those are basic ones. Let's make them just a little bit more complicated. I have 5, a to the third, b to the negative 2. Now, when I look at this, the only term that is negative, the only one that's unhappy is the b. So I have to move only the b. The 5a cubed is going to stay the same because it's positive and their exponents are happy. B to the negative 2 moves to the denominator and becomes b to the positive 2. And that's your final answer. Now this time, it's a simple looking problem, but it's the opposite of what we were doing before. This time, x to the negative 5 is in the denominator. So in order to make it happy, I have to move it to the numerator. That makes it x to the positive 5. And I can replace it with a 1. Now I can leave it like that, or I can simplify that problem as x to the 5th. I don't have to write 1 in the denominator. All right, in number 7, 4c to the negative third b. The only term that's unhappy is c. Okay. So what's going to stay in the numerator is the 4b. The c has to move to the denominator to become positive. So when it moves, it becomes c to the positive 3. All right, finally, in number 8, the n has a negative exponent. The m has a positive exponent. So that m ends up staying put because it's already happy. It has a positive exponent. The n is not. So the n has to move to the denominator, make its exponent positive, and be replaced by a 1. Right? Now just a couple more problems here. These put every exponent rule you've done in topic 1 and topic 2 together today. Simplify each expression. So I'm going to start with this fraction here by taking the negative 3 and distributing it to the 2, to the x, and to the y. So what I get is 2 to the negative 3 times x to the 6 to the negative 3 all over y to the 4th to the negative 3. Now I wrote that out the long way just so we could see what was happening here. Now I'm going to simplify. I'm going to leave the negatives how they are for now. So I'm still going to have 2 to the negative 3, but I'm going to do power to power here. So that gives me x to the negative 18th all over y to the negative 12th. Now that I've simplified and gotten rid of parentheses, now I can move things in the fraction. Well, everything is negative exponents, which means that everything is unhappy. So I'm going to write a new fraction. The 2 to the negative 3rd is going to go to the denominator and become positive. The x to the negative 18th is going to go to the denominator and become positive. And then y to the 12th moves to the numerator and becomes positive. Right? We're almost done now. The only thing left to do is simplify 2 to the 3rd. So I get y to the 12th. 2 to the 3rd is 8. And then x to the 18th. That's the final answer. Not hard, but we have to remember all of these exponent rules in order to be successful. All right, our last problem here on the notes. Same thing, we're going to distribute the negative 2 to the a, to the 5, and to the b. So I get a to the negative 2nd, 5 to the negative 2nd, and b to the negative 2nd. I don't have to simplify anymore except for moving all the negatives. A to the negative 2nd moves to the denominator to become positive, a to the positive 2nd. 5 to the negative 2nd moves to the numerator to become positive, and so does b. Now the only step left to do is to simplify 5 squared, which is 25. So I end up with 25b squared over a squared. All right, there's some practice on the bottom of this page. There's a short lesson video posted on Canvas if you have questions.